Here we're going to look at example 5 where we multiply binomial radical expressions. So the main question, what is the reduced radical form of each product? So we have the cube root of 7 times the quantity 2 minus the cube root of 49. When you're multiplying, you can multiply a radical and a constant, a radical and a radical. The index does not need to be the same when you are multiplying like it was in the previous example where we're adding or subtracting. So what we're going to do is we're going to distribute this radical 7, or the cube root of 7, sorry. So cube root of 7 times 2 would be 2 cube root of 7. We can't do anything else with that. The 2 is on the outside, the 7 is on the inside of the radical. The 7 can't be reduced, so we're going to leave that alone. And then this will be minus the cube root of 7 times the cube root of 49. Right, and we can combine those. There are the same index, so we can combine this. So I'm going to show all the steps. As you get better at this, a lot of these steps you can cut out. This will become 7 times 49. So we'll just keep going. That first term is not going to change. 7 times 49 is 343. 343 is in fact a perfect cube. The cube root of 343 is 7. So we would have minus 7 here. Now, these two terms, as we talked about in example 4, if we're trying to subtract anything, we need like radicals, so they have to have the same index and the same radicand, which these clearly do not. So that is our reduced radical form. We are done with that one. All right, part B, we have a binomial times a binomial. You've seen these before. Sometimes you've seen them with radicals, sometimes you have not. But all of this is a series of distribution. So we just need to multiply all of our terms, and we can go from there. Once again, I'm going to write everything out. You don't need to show every step as you get better at these. But this is going to be 2x times 2x minus 2x times radical 3 minus 2x times radical 3 plus, oh, sorry, let's not put that. Yeah, plus, and then we'd have radical 3 times radical 3. Okay, and let's do some highlighting here so we know what's coming from where. That 2x is going to be right there. This 2x was this expression here and here. This radical 3 was here. And nope, not there. Was this one here and here, and then finally this radical 3 was here and here. Most of the time you're not going to show that step, so we'll jump to what you would jump to this next step most likely. So you have 4x squared minus 2x radical 3 minus 2x radical 3 plus radical 9. Right, it's 3 times 3. They're both inside the radicals, same index. We can multiply them. 4x squared, we're not going to do anything about it. Can't be changed. These two are like terms, same radical, same index. So negative 2x minus 2x would be minus 4x, and the radical stays the same. And then the square root of 9, or radical 9, would be 3. So we would have 4x squared minus 4x radical 3 plus 3. Again, most likely this step right here you're probably going to be skipping, but I just wanted to remind you of how we multiply everything out. That's it.